great planners, Thabang Mongatane. This lesson is brought to you by the in collaboration with Siboney Discovery Center and broadcast by Pagama Research and Development. Welcome, grade 12s, once more after a long holidays. If you'll be having a question during the lesson, please WhatsApp us on 063 629 3655. Let me repeat the number again. Please, if you'll be having a question, please WhatsApp us on 063 629 3655. Let me repeat again so that you get it. 063 629 3655. Today, grade 12 will be looking at capacitor and capacitance. We know that we need to always go back to the structure of the examination, because now we're preparing for prelim that will be coming soon, and also for final exam that will be coming in the fourth term. Mechanics, the paper one is situated like this, grade 12s. Mechanics, it has 90 marks and it weighs 62%. And then electricity and magnetism, it has 33 marks, which it weighs 22%. Wave, sound and light, it has 24 marks, which weighs 16%. The total marks of the paper, which is paper 1, is 150 marks, and you'll be writing for 3 hours. We continue by saying the paper 1 will be summarized in this manner. We have 10 multiple choice questions, which takes 20 marks. Section B will be structured or a long question, which is out of 130 marks. And in the paper, as we said, is out of 150 marks. And the duration of the paper is 3 hours. That means after 3 hours, we stop you. You can't write anymore. Okay. And the topic that we'll be dealing with today, out of 150, it takes 18 plus minus 18 marks. Capacitor. What is capacitor? Define a capacitor as a device for storing electrical charge. That means when we ask you in exam to define a capacitor, in simple terms, you must say it's a device that stores electrical charges. Are we together, grade 12? And then this is how our exam guideline define capacitor. And then because we have a capacitor, we'll be having capacitance. We say capacitance is made up of a capacitor is made out of 2 plates separated by a dielectric or insulating material. Insulating material can be anything. It can be air, it can be paper, it can be glass, it can be plastic. That means when we talk about dielectric, we're talking about what? Insulating material. Are we together, grade 12s? We say, where do we use the capacitors in real life? Capacitors, they are used in technology for what? Like, for instance, we found capacitors as a component that is used as a filter in a circuit in a power supply, or also is what is separation. It used to separate the frequencies between the hoover and the hoover of the speaker and the tweeter. That means it gives you the high pitch. Are we together? That is where capacitor is used in technology. And lastly, it is used in what? Filtering the noise. Like for instance, the reason why now, because now we have a good quality capacitors. That is why when you buy a sound system or a TV, you can hear what the sound clearly. Unlike in the olden days, because our capacitors then they were not of good quality. Grade 12s, when you open your TV or your system, you'll find something like this. This is what capacitor looks like. If you find anything looks like that, you must know that it is what? Capacitor. You can see that they comes in different shapes and different size. It depending on what? On the device that you found it. Are we together, grade 12? We continue. This way, what you see here are the formulas that we'll be using to calculate what? Capacitance. Are we together, grade 12? And these formulas, they come from exam guideline. We didn't think them by themselves or by ourselves. We say the first one will be, let's look at this one here, which says C is equals to Q over V. That means in this formula, to calculate capacitance, you need charges. We need a charge and a voltage. Are we together, grade 12? And then we'll be looking at this formula. Before we look at this, I want to look at this one, the simple one. Here, we'll need what? It depends, to calculate the capacitor here, we'll be looking at the area and the distance between the plates and the permeability of a free space. What you see here, this E with a subscript O is what? Permeability of a free space. And A is for what? Is for area, and D is for distance between the plates. Okay, and C we said is for what? Is for capacitance. And then when you look at this formula and this formula, there is only one difference. This is the difference is this. It's K. K is for what? We say K is the constant of what? Is the constant of the material that's used to make the dielectrics. Changing the material, it means you change the value of K. Like for instance, I forget to tell you about the permeability of a free space. Permeability of a free space is a constant. It is equals to 8,85 times 10 to the exponent negative 12. Are we together, grade 12s? Yes. You'll see as we go on. Like for instance, this formula is the one that we started with, that say a capacitor is equal to a charge divided by what? By a voltage. And then this formula, when you look at it, it means that when you increase the voltage, that means you are decreasing what? The capacitor. But when you decrease the charge, also you'll be decreasing what? The capacitor. That means you can see that the capacitance and the voltage, they are inversely proportional to each other. But the capacitance and the charge are directly proportional to each other, meaning that increasing capacitor, you'll be increasing the charges on the capacitors. Are we together, grade 12s? Okay, let's continue. It says here, define capacitance as the amount of charge it can store per volt. Are we together? We're looking at what? The amount of charge. When you see this Q, it means what? The Q there is for what? Is for the amount of charge. And then the V is what? Per volt. Are we together? We're talking about voltage. Okay? We can see there we're saying what? C stands for what? It stands for a capacitance, and it is measured in F. F is what? Farad. F stands for Farad. Are we together, colleagues? It's from our scientist, Farad. He's the one who discovered the capacitor. Okay. And then now Q stands for what? Charge, the amount of charge. And it's measured in what? The charge is measured in coulombs. Are we together? It's measured in coulombs. Then we go to the voltage. V stands for what? Voltage, and it's measured in what? In volts. When you see V, you know that is what? Is volt. And when you see C, you see we have a, don't confuse this C with this C. This C is the unit. It's the SI unit. It stands for what? Coulombs. Are we together? And this C that you see here, it stands for what? Capacitance. Are we together, grade 12? Yes. We go on. We're looking at another formula. The two formulas that we talked about before. Let's start with, when you look at these formulas are grade 12s. You don't have to memorize them. Each and every test, each and every exam that you'll be writing, you'll be given a formula sheet that contains these formulas. What you need to know is to know, what you need to do is to do what? To know when to use each and every formula. Are we together, grade 12s? Yes. Let's look at the what does this formula mean to us. Are we together? We'll look at both of them at the same time. You see, this C is the same as this C, grade 12. Are we together? Then we say C stands for capacitance, and it is measured in farad, as we said. And then E epsilon O, or subscript O, stands for what? Permeability of a free space, and it is a constant. Constant, it means it doesn't change. Whether it's a Christmas day, whether it's a Good Friday, whether it's Sunday or Monday, it doesn't change. It always remains the same. It remains what? 8.85 times 10 to the exponent negative 12. And then it is measured in what? Farad per meter. Farad per meter. Are we together, grade 12? Yes. And we say A, which is this A. This A that you see here is the same A that you see there. It stands for what? The area of the plate. We said at the beginning that capacitance is made up of two plates which are separated by what? Dielectrics. Are we together, grade 12? That means you'll have two plates like this. And then you can see that the distance here, there's a distance between the two plates, and then the distance, the space between the two plates, that's where you get what? Dielectrics. A dielectric is any insulating material that you can use. It's either air, it's either plastic, it's either paper, it's either glass. Eslo?
Welcome to today's lesson. Hoping that you have enjoyed the capacitor and capacitance. Today we'll be focusing on electrochemistry. Remember, electrochemistry is question 5 and question 6. In question 5, we have electrolytic cell. Question 6, we have galvanic cell. So make sure that you do understand this topic. A lot of marks that you can collect for paper 2. So I'm hoping that you will understand and we'll move together. Now, if you check the topic, here is under chemical change. See chemical change? As indicated there, we have 28 marks, which is 38% of paper 2. So you have to get that. Remember, paper 2 is 75 marks. 75 marks. For paper 2, you are writing for 1.5 hours, of which we have those levels. To say level 1, which is recall questions like with definitions. We have 30 marks, 35 marks, 30%. Level 2, we have 35%. Level 3, we have 30%. And level 4, we have 5%. So you can see those are levels of difficulty for the paper. I will go straight to the topic because I want us to be able to move and so that you can see your understanding. But if we check how the learners of previous years performed in this topic, look, question 5, which is electrolytic cell, we were at 31%. The topic we're going to do today is galvanic cell, and galvanic cell is question 6, we're at 29%. So you can see that we were not doing that much well in terms of that topic. I'm hoping that you will understand at the end of this day, you will be more comfortable to deal with galvanic cells. So that is the topic we're going to deal with. Now, in grade 10, remember, you have done the pure substances, which you refer to as elements and compounds, wherein we said elements are substances that cannot be broken down into simpler substance by chemical means. For example, if you are having zinc, it's an element, it's an atom. You can't be able to break it down. So we refer to it as an element. But a compound, it means we have more than one, which means it's a substance that consists of two or more elements. So when you have two or more elements, we now refer to it as a compound. For example, you can have your carbon dioxide, you can have your water. You can see you have two or more elements. So when you have two or more elements, we refer to it as a compound. When we have only one that cannot be broken down, we refer to it as an element. So you have to know that in this section, we'll be dealing with the elements. I gave zinc as an example of an element. We'll be dealing with a compound. I can give you, for example, copper sulfate. You see, it's more than one elements that are making copper sulfate. So that would be a compound. Zinc itself is an element because it's on its own, but copper sulfate, you will refer to it as a compound. So you have to know that. And remember in grade 10 as well, you have done naming of compounds. You have done the table of negative and positive ions. You will remember when you were dealing with sodium chloride, you were saying sodium is positively charged and chlorine is negatively charged. Just to recap where you're coming from. So you have done the negative and the positive ions. And then we were going to look at the charges. Remember in the periodic table, we have group 1, which usually have a charge of positive 1. Remember a positive charge, when an element or when an atom loses electron, what is going to happen is that it is going to be positively charged. So when you see a positive charge, you must know that an atom has lost an electron. For example, if you are having sodium, when it loses electrons, it becomes sodium plus an electron. So that positive, it shows that now we have more protons than electrons. The element is no longer neutral. So we are saying all the elements that you see in the periodic table, they are neutral. But upon losing an electron, they will become positively charged. So all the time when you see positive charge, you must know that there was loss of electrons. The same with negative. When you see negative, you must know that there was gaining of electrons. So when there is gaining of electrons, there will be negative. For example, if you're having Cl2 plus 2 electrons forming 2Cl minus, you can see that this Cl, there was no charge there, but now it's charged. It's charged, negatively charged, which shows that it has gained electron. So when you gain electron, you become negatively charged. When you lose electrons, you become positively charged. So you have to understand that all the time, when you see a positive, you know that there was a loss of electrons. When you see a negative, there was a gaining of electrons. Negative for electrons. Remember, the electrons are negatively charged. So when you see a negative, you know there was gaining of electrons. When you see a positive charge, there was a loss of electrons. So metals in group 1 in the periodic table, they lose electron. So group 1 element, they lose 1 electron. Hence, they form a charge of positive 1. Remember that charge, you said in grade 10, you were referring to the positive charge as a cation. So cation for negative charge. However, the negative charge, you refer to it as an anion. So you have to remember that. Those are small basics that you have done in previous grades, grade 10 and 11, that you must always remember that, okay, when I say a cation or when I say a positive charge, I must know that there was loss of electron. If it's a positive 2, it means that 2 electrons were lost. If it's positive 3, it means that 3 electrons were lost. But now the same with the negative. When you see negative 1, it shows that 1 electron was lost, but was gained. When you see negative 2, it means that 2 electrons were gained. So always you will look at that. This section is highly going to be dealing with those charges, the positive charge and the negative charge. So you have to remember that at all times. Now, as well, you have done metal and materials, which was your metals, your semi-metals, and your non-metals. Remember, metals, we are saying they are good conductors. So metals, they are good conductors of electricity, of heat. So they have between 1 and 3 electrons in the outer energy level. Remember, those electrons, we refer to them as valence electrons. So the electrons in the outermost energy level, we refer to them as valence electrons. So group 1, group 2, group 13 elements, when you see them, you see these are metals. They are more likely to lose electrons. Why is it so? Because their electrons are very loosely bound, which means the electrons are not tight. They are not holding tight to the molecule, to the atom itself, remember, the electrons are being attracted to the protons. So these electrons which are outside on the outer energy level, they are not firmly bound. They are loosely bound. That's why it's easy for group 1 elements, group 2 elements, group 13 elements, all these which you refer to as metals, we're saying it becomes easier for them to lose electrons. However, if you look at non-metals, they are poor conductors of electricity, and they contain the valence of 4 and 7. So it's 4, 5, 6, and 7 valence. These electrons are firmly bound. So you must know that it's not easy to remove electrons from non-metals. Like your chlorine, for it to be able to lose electrons, there is a lot of energy that we must use to remove that electron. We'll talk about that when we deal with electrolytic cell. However, for today's section, you have to understand that we are moving from a place where we are saying metals have valence electrons or electrons in the outermost energy level, and those electrons are not firmly bound, so they can easily be lost. However, non-metals, their electrons are firmly bound, which means they are holding on to the structure. It's not easy to remove those electrons. Hence, mostly during this galvanic cell, you will see when you have a metal and non-metals, you will see the metals losing electrons and the non-metals gaining electrons, which is what we're going to deal with. The other thing that I want to bring your attention to is that, however, carbon, you see carbon is as well, it's not a metal, but as well, it can be able to conduct electricity. So the charges can move through carbon, even though it's not a metal. So it's an exception. Remember when I started, I said these metals themselves, they are good conductors. However, non-metals are not good conductors. So I'm saying carbon is an exception because it's a good conductor of this electricity. So it's not a poor conductor, it's a good conductor. So we are referring to that. This is the predictable. So as much as you are dealing with paper 2, you must have a friend called a predictable. Spend much time looking at the predictable, understand what it means. Because if you look, you will see, I was referring to group 1 elements, which is this one. Most of the time, we'll be referring to LINAC, which is lithium, sodium, and potassium. So those ones are group 1 metals. So that is the alkali metals. We refer to them as alkali metals. And then we have the group 2 elements, that is where we are having beryllium, magnesium, and calcium. We refer to those alkali earth metals. They are group 2. So group 1, as I indicated in my introduction, to say group 1 elements, they will lose 1 electron, which means they can form a cation with only positive 1. So it becomes very difficult to remove another electron from group 1 elements. So the one that is loosely bound is the 1 electron in the outermost energy level that we refer to as valence electron. So these are group 1 elements, group 2 elements. If you see group 2 elements like magnesium or calcium, you will see they will lose 2 electrons. They will lose 2 electrons. So you have to know that the group 1, they will lose 1 electrons. The group 2, even if you see, for example, sodium chloride, you have to know that sodium, because it's a group 1, is going to lose 1 electron. And chlorine, because it's a group 17, is going to gain, because the non-metal is going to gain the electron from sodium, which means we'll have a sodium plus and a chlorine minus. So when you see sodium, you must be able to see it in that fashion. The other compound that I would like you to understand as we are starting with our introduction is our so you will know that we are dealing with zinc and copper chloride, the sodium chloride and the copper chloride. This one is very much important as well for you to know that chlorine is group 17, it's a non-metal, so it can gain 1 electron as I indicated in the start. So you will always have -1 there. Then you have 2 chlorines, which means the copper will be +2. We'll understand as we go inside. But for now, however, I want you to be able to look at the predictable and say the group 1 elements, they can lose 1 electron. Group 2 can lose 2 electrons. Group 13 with more emphasis on aluminium, we are saying can lose 3 electrons. However, group 4, we say plus or minus, which means they can gain or lose 4 electrons. Group 15, we are now saying minus 3, which means they can gain 3 electrons. Group 16, where we have oxygen, they can gain minus 2, which is 2 electrons. And then group 17, they can gain 1 electron. So you have to understand that, okay, group 18, these are, we refer to them as noble gases. They are inert, they are not reactive. So they cannot gain or lose electrons because they are fully filled. So in real essence, when the metals look at group 18, they would like to be like group 18. They would like to lose electrons so that they become stable, because this group 18, is very stable because all the electrons, they are fully filled and all the electrons are paired there. So all of these atoms or elements that we are seeing here, they would like to be like group 18. Hence, when sodium loses electrons, it becomes difficult for it to gain another electron to go backward. We'll talk about that when we do electrolytic cell. So I hope you have the periodic table with yourself, and then all the time when you are doing paper 2, you will have the periodic table and you will be the friend of the periodic table, because paper 2 is centered on this periodic table. So you have to understand all the time. As you look on it, you are able to say, I understand. Group 1 elements, they can lose 1 electron. Group 2, they can lose 2 electrons. Group 13, with more emphasis of aluminium that I've been making, we are saying they can lose 3 electrons. However, group 14 was said plus or minus 4, which means they can lose or gain 4 electrons. When you go to group 15, they can lose gain 3 electrons. So on the right is the gaining of electrons. On the left, we are having the loss of electrons. So it becomes easier if you are given sodium and chlorine. You can easily know that a metal would like to lose electrons, a non-metal would like to gain electrons, which is just a spontaneous reaction, which means the reaction doesn't need any energy to be added. The reaction can take place without addition of electrons. I hope you have understood the periodic table and we are moving because it's going to help us. Now, in grade 11, you have done these definitions. You have done what is oxidation. Oxidation, you have done what is oxidation, which you said are loss of electrons. Leo. So you referred to oxidation as loss of electron. So when you say Leo, I'm saying loss of electron is oxidation. So this is revision of grade 11, because we are still going to ask you this question to say, define what is oxidation, define what is reduction, what is an anode, what is a cathode, what is a reducing agent, what is an oxidizing agent. Still, they use the understanding of oxidation numbers is very much important here. And electrolysis as a process. Remember, you have done the electrolysis of copper chloride in grade 11. So it's very much important for you to come with that knowledge that you are having. So we're not wasting your time in grade 11. We're preparing you for grade 12. So we're saying loss of electron is oxidation. Gaining of electrons is reduction. So we're saying gaining of electrons is reduction. So it's Leo the German. So you can see there. We are saying all the time, remember these mnemonics, we are saying Leo stands for loss of electron is oxidation, while GR stands for gaining of electron is reduction. Now, when a substance loses electron, I gave you a nice example of sodium to say it's a metal, it would like to lose electrons. So when sodium loses electron, like that. So when sodium loses electron, we say sodium is undergoing oxidation. Oxidation, which means its oxidation number is increasing. Remember, I have to bring it to attention to say, when you look at the periodic table, all those elements, all of them, they have oxidation number of 0. So as they appear there, they are neutral. They don't have no oxidation number because they haven't lost or gained no electron. But when sodium, for example, when a metal loses electron, it becomes now a metal ion. Like sodium becomes sodium plus. The plus there is showing that we have lost 1 electron. So you have to know that the oxidation number will increase. Hence, we are referring to the process as oxidation. This is oxidation. What is oxidation? It's loss of electron. So when we lose electron, we are undergoing oxidation. So you can see that sodium is undergoing oxidation, which means its oxidation number is increasing. Now, the other thing that I want to bring to your attention is that when sodium loses electron, undergoes oxidation, which we said Leo. When sodium undergoes oxidation, which you refer to as Leo, we are saying to yourself that remember, sodium is referred to as a reducing agent. So we're going to say the substance. What is the reducing agent now? It's a substance. A reducing agent would be a substance that undergoes oxidation. So you can see now, you know that a substance that undergoes oxidation, we refer to it as a reducing agent. So you have to know that the one that is losing electron becomes the reducing agent. Why? Because remember, it's losing electron, that is negative. So it's removing electrons from itself. So it becomes an agent for reducing another atom or another substance. We refer to them as substance. So most of the time, you will hear me talking to substance. When I say substance, you must know that I'm referring to these three things. So when I say substance, I'll be referring to an element, like sodium, it's an element. I will be referring to a compound, and I'll be referring to an ion. So when I say substance, a substance can be an element, compound, and ion. This section is all about these three things: an element, a compound, and an ion. So when I say substance, I'm referring to those three. Sodium is a substance. So sodium substance can do what? Can lose electron undergoing oxidation. And we refer to sodium as reducing agent. It's an agent for reducing because it's losing electron, so it's making it possible for another atom or for another substance to undergo reduction. Hence, we refer to it as a reducing agent. So, lastly, I will say when I talk to oxidation, loss of electron is oxidation, as I've indicated there, and we are saying a substance that undergoes oxidation, we refer to it as a reducing agent. So, if we say define a reducing agent, you will say it's a substance that undergoes oxidation. Say, will I be wrong if I say it's a substance that loses electrons? You are still correct, because when a substance loses electron, it's undergoing oxidation. And we refer to a reducing agent as well as a substance that is oxidized. A substance that is oxidized. For example, sodium is oxidized to sodium plus. So you will know we are saying now Leo Rao. Don't forget that. So you know that loss of electron is oxidation. And we refer to that substance as a what? As a reducing agent. What is a reducing agent? It's a substance that undergoes oxidation. And that substance is oxidized. It means its oxidation number increases. You have seen with sodium here, it has the oxidation number of 0. Now it has a oxidation number of +1. So when you see the oxidation number increasing, you know that is oxidation. Because in some of the questions, we'll just give you the equation. You have to determine which one is undergoing oxidation, which one is undergoing reduction. Now, when a substance gains electrons, I gave you an example of chlorine, where we said, okay, if we have Cl2 that gains 2 electrons, and then that will give us 2Cl minus. So you can see, when we start here, the chlorine here has nothing, so the oxidation was 0. But because it's gaining electrons, it becomes minus. So when a substance goes that, so what do we refer to this? We say gaining of electron is reduction. Gaining, you can see chlorine was at 0. Now it's at -1. So obviously it shows that it's gaining electrons. When you gain negative, you are undergoing reduction because you're not gaining something positive, you are gaining negative. Hence, gaining of electrons is reduction. So don't forget that gaining of electrons is reduction. And then we will refer to this chlorine now as the oxidizing agent. What is the oxidizing agent? You will say it's a substance. Remember I said we're talking about substance here. So oxidizing agent is a what? It's a substance that undergoes reduction. So you have to know that the oxidizing agent is the substance that undergoes reduction or the substance that gains electrons. And you can see with your chlorine there, it has oxidation of 0. Now it's -1. So you can see that it's reduced. It's reduced from Cl2 has been reduced from 0 to -1. So you know that, okay, this is reduced. So we say Geroa. So I want you to remember, not to forget that we are saying loss of electron is oxidation, and the substance that undergoes oxidation, we refer to it as the oxidizing agent, and that substance is oxidized. So remember that at all times. Now, when it comes to this one, we're saying gaining of electron is reduction. A substance that undergoes reduction, we call it oxidizing agent, and that is reduced. So these mnemonics, you must remember them at all times because they will help you. You will remember. You must collect all these marks. When it comes to definitions, you must sing all the definitions. So don't forget these mnemonics, Leo Rao and Keroa, to remember all the definitions that we've done. So if you can check, we were able to define oxidation, we're able to define a reduction, we're able now to define what is a reducing agent, what is a oxidizing agent. So now there are only two things that we didn't define there, which is the anode and the cathode. So you will see from the word anode itself, anode, cathode. So you have to check. Now you can see that this is ode. Ode is from the word electrode. So an anode is an electrode. It's an electrode where oxidation occurs. So, or take place, whichever choice of words. So is the electrode anode, this one, the first one, is the electrode where oxidation takes place. So this one, which you said is Leo Rao, it goes with what? Anode. So anode is an electrode where oxidation takes place. A cathode is an electrode where reduction takes place. So here you must know that we go with the cathode. I'm intentionally writing the T as a positive so that you don't forget where this is coming from. Remember, we said anion and cation. Remember those two words? Anion and cation. So you can see this electrode, it has to do with anions. So we're going to talk about that. The anion are going to move to the anode. We'll talk about that when we talk about galvanic cell, which is what we're going to start now. Cation, cathode, obviously you can see, or in this electrode, we are going to have cations coming towards the cathode. So you have to understand all these definitions before we start. You have done them in grade 11. You are revising them, and we're still going to ask you questions based on these definitions. So I'm hoping I made it easier for you to define, and you are ready now to start with the topic itself. Now, the definitions, as I was trying to use the mnemonics, you can see Leo Rao there, nicely said for you there to say is loss of electron is called oxidation. It's a reducing agent. Don't forget what is a reducing agent. We said it's a substance that undergoes oxidation from there, reducing agent, and then it's oxidized. So you have to know what that stands for. Now, Gero, we said gaining of electrons is reduction, and we said is there we have the oxidizing agent, and the oxidizing agent is what is reduced. So you have to know that always the oxidizing agent is the one that is reduced. So when you look at the oxidation number, it must decrease because it starts with a bigger oxidation number. I've shown you that with chlorine, where chlorine started with SCl2 with oxidation number of 0. But now it was reduced to -1. So you have to understand that immediately when we move, that's how we move. You are able to do that. And we said the oxidizing agent is a substance that undergoes reduction. Oxidizing agent is a substance that undergoes reduction. I told you about what is an anode. We said ode there from the word electrode. You can see we have used the suffix there, ode, from the anode, ode, taken from that. So you must know that always you will start by saying an anode is an electrode. A cathode is an electrode. What is happening at the anode is where oxidation takes place. A shortcut is to say an ox. An ox, you will remember what an ox stands for. You will remember that, okay, anode is where oxidation, electrode where oxidation takes place. And we are saying red cat. Red cat, what are we saying? Cathode is where reduction occurs. So you have to know where reduction takes place or where reduction occurs, that is your cathode. Where oxidation occurs is anode. So an ox and red cat. So you will remember that. Now, when we refer to this galvanic cell, we can call it, this is question 6. You can refer to it as a galvanic cell or as a voltaic cell. So it's the same. Question 6, but dealing with the galvanic cell and voltaic cell. But the most popular name with most of us is galvanic cell. However, it's the same. It's galvanic cell or voltaic cell. So now here, when we deal with galvanic cell, we're going to have energy conversion. We're going to have changes in energy. So you must know that in this galvanic cell, it converts chemical energy to electrical energy. So you have to know, when you say define galvanic cell, it will tell us about energy conversion. To say energy is converted from chemical energy to electrical energy. So you have to know that galvanic cell is a what? It's a cell. That does what? That converts chemical energy to electrical energy. So it means if you can look at the name voltaic, you can see that volts can be produced. So you have to know that it must be chemical energy to electrical energy. So that is the first thing that you must know now in terms of your grade 12. To say, I have to know that all those definitions we're doing, you have to know all of them as they will be assessed in grade 12. And we're saying now here, the first thing you must know what is galvanic cell. So we're saying galvanic cell is a electrochemical cell that converts chemical energy to electrical energy. The keywords are the ones that I have underlined. So they must be there in your definition. You must have it converts chemical energy to electrical energy. Now, this galvanic cell, we say it is spontaneous. I talked about that. Remember when I was saying metals will easily lose electrons and non-metals would easily want to gain electrons. So it's spontaneous. It's not a process that is forced. We don't need any energy. We don't use any other energy source in order for this process to occur. It occurs without addition of external energy. So hence we refer to it as spontaneous. We don't push it. It happens spontaneously. Metals will simply lose electrons and non-metals. Maybe you might be thinking, is this redox reaction happening amongst only metals and non-metals? No. You will have two metals. For example, our favorite galvanic cell is called zinc copper cell. Zinc metal and copper metal, they are all metals. But one will have to lose electron, the other one will have to gain electrons. So this is the center of our discussion today, to say if we have two metals like zinc and copper, which one is going to gain electrons, which one is going to lose, and why? Why this one loses, why this one gains. That is the essence of us being here and having this lesson. This we say this is exothermic. You remember exothermic means energy is given off or energy is released. Remember, we're having chemical energy. Now it becomes electrical energy. So we don't add energy. It's not endothermic, it's exothermic. Now, a brief history. We won't ask you about the history of the galvanic cell in the exam, but you have to understand, I thought it would be very much important for you to understand where this is coming from. So we're saying a galvanic cell or a voltaic cell is named after the scientist called Luigi Galvani. So the name galvanic is from that, Luigi Galvani and Alessandro Volta. Volta for voltage, respectively. So this cell is, we talked about that to say electric current is generated from spontaneous redox reactions. So these are the people who did a lot of research on this galvanic cell and voltaic cell that we are doing today. So I thought it would be important that you know where the names are coming from. Now, there are common apparatus that we use during this galvanic cell. Usually we'll have two different metals usually, and then each is immersed in separate beakers containing their respective metal ions in a solution. The solution that we use here, we refer to it as an electrolytic solution. An electrolyte is a solution that conducts electricity. So you have to understand that. It will be here in my notes, but I felt it's important that I emphasize that, because we are saying we're going to have metals. These metals must be inside an electrolyte. What is an electrolyte? It's a solution that conducts electricity. Because remember, we want to be able to convert the chemical energy to electrical energy. So we need a solution that will help us in that process. That solution is referred to as electrolyte, which is a solution that conducts electricity. I hope that will help you. The other thing which is very common and very important in a galvanic cell or voltaic cell is what we refer to as salt bridge. Salt bridge. So you must know, anyway we're going to do examples, you'll be able to see what we're talking about. Now, this will be your chemical change, your electrochemistry. Then you are able now to see. We're having, remember what I was saying, we're having zinc here, and we're having copper this side. So we refer to this side here on my left, this side, we refer to it as the zinc half cell. So it's a zinc half cell because we're having zinc this side, and this side is a copper half cell. So this is a zinc copper cell. So we refer to the cell as a zinc copper cell. Remember what I was saying, to say in this case zinc is a metal and copper as well is a metal. So we can still might as well have two metals that are immersed in the electrolyte. Remember, we said there must be an electrolyte. So you are having your zinc here, is inside the electrolyte. The electrolyte, we said, is a solution that conducts electricity. And if you check, our electrolyte is zinc sulfate. Zinc sulfate. So then what is of importance here is for you to understand that a sulfate is a SO4 2-. That shows that zinc is a zinc 2+. Hence here you will see we've indicated zinc as a zinc 2+ and sulfate as a SO4 2-. So you have to know. Remember, this sulfate now is there, is your spectator ion there. The zinc 2+ is the one that we are mostly interested in. Hence, when you look at this, we are saying that zinc is the one that is going to lose electron to become zinc 2+ plus 2 electrons. And then copper will gain electrons to become copper. So I hope, I'm thinking that you're asking yourself a question to say, why is zinc the one losing electrons and copper, copper 2+, being the one that is gaining electrons? So you will see if I will come back. I just want to go to this slide that will be able to help you in terms of how we came to that. So if you look, we have a table that is referred to a table 4A, and we have another table that is referred as table 4B. You will see, maybe you have seen when you're doing a revision, when your teachers at school, they give you the previous question papers, there are two tables there at the back. So those tables, we refer to them as table of standard reduction potential. So the word potential, you know the meaning of the word potential is ability. So it's the ability to do a reduction. I just told you that reduction is gaining of electrons. So we're saying this table, it shows you the ability of substance to gain electrons under standard conditions. Standard stands for standard conditions. So I want us to focus on that. Before we go back to the zinc copper, I want you to first understand this table, because this table tells us which one will lose electrons, which one will gain electrons. So it's very much important that I start from here, so that when I go to the zinc copper, you are able to understand. So now we are simply saying, if you look here, we're having our zinc and copper. So in this table, we are showing the ability to gain electrons under standard conditions. So you know, gaining of electrons, which means the substance here that is a bigger standard reduction potential. So these are the standard reduction potential that I'm referring to. So a substance that is a bigger or a higher standard reduction potential, we will gain electrons. So the one with bigger number, if I'm in simple ways, if I was to simplify this, the one with the bigger number will lose electrons. So we're having zinc, we're having copper. So we'll be asking ourselves that question. Now, without any wasting of time, let me move back so that we move together. Now, if from that table, you will realize that zinc is written like that, zinc with negative 0.76 volts. So the standard reduction potential for zinc is negative 0.76 volts. So you have to know that, okay, it's negative 0.76. And then for copper, it's copper 2 plus 2 electrons forming copper. So the standard reduction potential there will be positive 0.34. You see, now, if you remember, I said that table shows you the ability to gain electrons. So the one, you can see already that copper has a higher ability because it has standard reduction potential of 0.34. So when you're going to that table, it's telling you that the one with the bigger ability, the one with the highest standard reduction potential will gain electrons. Hence, copper is gaining electrons. Zinc, because I'm saying to you, is negative 0.76 volts. So it has a lower ability to gain electrons. Hence, zinc will lose electrons because it doesn't have a higher ability as compared to copper. Copper has a higher ability. So copper must gain electrons because it has a higher standard reduction potential. So which means you have a memo in terms of your table. That table 4B will be using it a lot in terms of question 6, in terms of galvanic cell. You can use the table any way you want. You can use all of them. You are not restricted. However, I would like to advise you to say, if I'm using, the one that I'm using here for example, I'm using table 4B. I'm saying in table 4B, you will see that it starts with the negative, smaller numbers, then they increase with the bigger positive numbers. So it makes our lives much easier when you are using table 4B for galvanic cell. Why? Because your duty is to identify, like in this case, we're given zinc, we're given copper. You'll go to the table, you will look for zinc and copper. And definitely you'll find that zinc is at the top and the copper is at the bottom. So it becomes very much important for you to be able to say, this is zinc. You will copy the zinc one and then the copper one. Remember, what is going to determine which one will lose electron or gain electron is the standard reduction potential. Now, because copper has the higher standard reduction potential, it will gain electrons, which means that zinc will lose electrons. Now, we immediately when you have a zinc and copper like that, you are able now to say, okay, this you can use the C or you can use the Z. I usually will just write Z there. When I write Z between them, the one at the top you can see is going backward, the one at the bottom is going there. So the first reaction, the one which is having a lower reduction, standard reduction potential, will reverse. The reaction with the lower standard reduction potential will reverse. So meaning that this reaction will start from zinc. Remember, when you copy from the table, it's in that way. But now you will start from zinc, then it becomes zinc 2 plus 2 electrons, which is what we are given here. So hence, it's in a reversed form. So the one with the lower standard reduction potential will be reversed. However, the one with the higher standard reduction potential will remain the same. It means it will be a forward direction like that. So I want you to remember that. And then remember what we said. We said the one that loses electron is undergoing oxidation, is the reducing agent, is oxidized. The one that gains electrons is undergoing reduction, is the oxidizing agent, is reduced. So I hope now you are moving with me. You are able now to see that, okay, zinc is undergoing loss of electron, so it's undergoing oxidation. Remember, we said for oxidation, the oxidation number increases. Zinc on its own is 0 there, but now it becomes +2 there. You can see there's a +2 there. So you know that zinc is undergoing oxidation. So we'll refer to zinc as a reducing agent. Remember, we said a reducing agent is a substance that undergoes oxidation. So we'll say zinc is oxidized. Oxidized means it has increased. So zinc has increased from 0 to +2. So you have, sorry for that, you have to understand at all times to say zinc now becomes zinc 2+, which means it's undergoing oxidation, which means it's losing electron, which means it's oxidized. Now, be careful here. The one that is gaining electrons is not copper, it's copper 2+, which means in the solution. Remember, copper 2+ is in the solution, but the metal itself is copper. This is copper. The solution is copper 2 plus. Don't forget, I indicated to you when we started that we have a copper sulfate as our solution. However, you know the sulfate SO4 2 minus, as we've done that from grade 10, and then with copper is copper 2 plus. So you remember that there you have your spectator there helping you there, but our focus there is copper 2 plus, to say copper 2 plus in the solution will gain electrons. Remember, zinc is losing electrons, so the electrons are moving the external circuit here. So you are having your 2 electrons moving from zinc coming this side. But let's talk about zinc first. When zinc loses electrons, it must be decreasing in mass. Remember, it loses electrons, the electrons are leaving, they're going this side. Here, zinc is becoming zinc 2 plus. So you will expect that this solution will increase. So the electrolytic solution, the electrolyte concentration of the electrolyte will increase, which means zinc sulfate will increase. But zinc, the metal itself, zinc, will decrease in mass. I want you to look at that because that is the question that we like to ask many of times. So you have to know that when zinc loses electron, because it's losing, it must decrease in mass. However, the zinc 2 plus, the solution, the electrolyte concentration of the electrolyte will increase. So what decreases is the zinc solid. Remember, we have 2 zincs here. It is zinc solid and zinc aqueous. So we're saying the zinc solid will decrease because it's the one that is losing electron. However, the zinc aqueous, which is the solution, it will increase because more of zinc 2 plus is formed. Then we see the migration, the movement of the 2 electrons, and to show that this is working, we are even able to connect a light bulb. But most of the time, you will see that we're going to connect a voltmeter there. We're going to connect a voltmeter that will show how much is the voltage here. We'll deal with that. So now, as the electrons move this side towards the copper or the cathode, what will happen? Remember, red cat, reduction takes place or occurs in the cathode. So you have to know that as the electrons come here, they react with the copper 2 plus from the solution. So you will expect that the solution here, the copper sulfate solution will decrease. Why? Because it's reacting with the 2 electrons that are lost by zinc. Remember, zinc loses electrons. The same electrons lost by zinc, they are being gained by copper 2 plus, which is the solution, the electrolyte. Our solution now will decrease. So the concentration of the electrolyte will decrease. The concentration of the electrolyte will decrease this side. What will happen to the copper now? Because more of copper is being formed. So you will have an expectation to say, since more of copper is being formed, it means that we will have an increase in mass here. So you will see the copper will increase in mass while the zinc is decreasing in mass. So you have to understand, the one that loses electron, the solution will increase. It will decrease in mass. The one that gains electrons, it will increase in mass and the solution will decrease. And you will see after some time, this light bulb will turn off because we will have utilized all the solution there. Remember, as the electrons are busy coming in, they are busy decreasing the concentration of the electrolyte. So when we have no electrolyte left, definitely we are going to have EMF now being 0, or the battery not functioning, or the light bulb will go off. So and it shows that we have reached equilibrium. It's something that you must know. So I hope now you understand how do I know which one will lose electron, which one will gain electrons. I said to you, we have zinc, we have copper, they are all metals. Now, because of that, we will go to the table of standard reduction potential. The one with the higher standard reduction potential. We said standard reduction potential is the ability to gain electrons. So you have to know the one that is going to gain, that is the higher ability, which means the one who is having a higher voltage there, which is in this case copper 2 plus. Copper will gain copper 2 plus will gain electrons, and zinc will lose. So you have to know that the table will assist you to determine which one will lose electron, which one will gain electrons. So now, if you can check, we refer to this as half reactions. You see, you say oxidation half and reduction half. The halves, when you combine them, we have the overall cell reaction. or net cell reaction. So you will see most of the time we'll say write down the oxidation half reaction. It will be zinc forming zinc 2 plus 2 electrons, and then we'll have a copper 2 plus 2 electrons forming copper. So you have to know when you do the overall or the net, you have to do like that. Then you are able to say we have 2 electrons on the left and 2 electrons on the right. Remember, all the time, before you do the overall or the net, the total here, the net cell reaction or overall cell reaction, you have to know that before you do that, you must ensure that the electrons are balanced or they are equal. If they're not equal, you must multiply them so that they become equal. So you must balance the ions, the electrons before you can write down the net or the overall cell reaction as we have indicated in that slide, to say this is the overall cell reaction. Then immediately when you cancel the electrons, you are able to say, okay, we have zinc plus copper 2 plus, that is forming zinc 2 plus copper, which is what we're having here. And then that is overall. That question, usually it has 3 marks. So you must write the oxidation half reaction, reduction half reaction, balance the electrons. When they balance electrons, what is on the left of the 2 reactions, the oxidation and the reduction? You write on the left, you write 1 arrow. Remember, the only time we're writing 2 arrows is when we copy them from the table of standard reduction potential. Immediately when you say this one has a lower standard reduction potential, it will lose electrons. The one that loses electrons, then you are using only 1 arrows. Hence we are saying they are half reactions, because you are using 1 arrow. We're not using 2 arrows. So you use one arrow, then you ensure that even in your overall, you are using 1 arrow when you add the 2. I hope you have understood that. Then I just wanted to further make you understand this question, to say, don't forget, we are saying zinc is negative 0.76 volts. Copper is positive 0.34. So definitely, it's like if somebody asks you for something you don't have. Look, this one is negative, electrons are negative. So the negative one, it must definitely have electrons. It must donate, it must lose electron. So the negative one will lose electron, and we said loss of electron is oxidation. So as I indicated, the loss of electron is oxidation, is a reducing agent, is oxidized. Don't forget, we said NOx. So we just showed that in the past we used to trade with the kettles and all that. So NOx will remind you that it's back then. So the one that goes back is the ox. The NOx goes back, which is at the anode. There is oxidation. It's the one that we reverse. I showed you the arrow there. But this is the one that we reverse. The smaller one is the one that we reverse. Is the one that is going backward. It's an ox, which means an anode. At the anode, oxidation takes place. So you can say oxidation is a loss of electron. This is zinc solid. It's losing electron to form zinc 2 plus, and then it has lost those 2 electrons. However, the copper, we said red cat. Red cat, we can only have red cats in the future. We don't have many red cats. So we are saying the one that continues to direction that continue, that remain the way it is the red cat. So is the cathode. At the cathode, we're having reduction that takes place. So you have to not to forget that. Hence, we even went to the trouble of showing you with the red cat and the NOx, to say NOx backward, red cat it goes forward. So the forward direction, the one that we don't reverse, the one that we copy as the way it is written on the standard reduction potential, is the one that is taking place at the cathode, where a reduction occurs. So you see that for reduction, you are copying the way it is, and then we're saying there will be gaining of electrons, and reduction will take place. That is the oxidizing agent. Remember, the agents are always on the left. So you can't here say copper is the oxidizing agent. No, copper 2 plus is the oxidizing agent. Zinc solid is the reducing agent. So you have to know that when I pretend there are 2 half reactions, the ones that are on the left, that's where I will get my agents. Remember, we said reducing agent is a substance that undergoes oxidation, and then we said the oxidizing agent is a substance that undergoes reduction, or that gains electrons, or that is reduced. So you are spoiled for choice in terms of that. So I hope this slide as well, it helps you to understand that, okay, the one that is the negative one would lose electron, which means it's undergoing oxidation, is the reducing agent. How did we know that zinc is the one that is going to lose? We looked for the standard reduction potential. So I want this example to be able to work for you so that for any other question that you come across, you will be able to go to that table and look for the standard reduction potential. So the one with the lowest standard reduction potential will lose electrons. However, the one with the high standard reduction potential will gain electrons. I hope I emphasize that more than enough, and you will be able to remember that. As I indicated, in the anode, we said there will be decrease in mass. So we see this one, there is decrease in mass there. In the cathode, we said there will be increase in mass. You can see the copper is increasing in mass. However, I indicated that when they decrease in mass, the zinc 2 plus, the electrolyte, will increase. So there will be increase in concentration of the electrolyte. And then the one that is increasing in mass, they must be decreased. So it's not that you decrease or you increase in everything. No. If there is decrease in mass, at least the concentration will increase. If there is decrease in the concentration, the mass will decrease. So I want you to understand that, to say, okay, in the anode, there will be decrease in mass, but there will be increase in the concentration. In the cathode, there will be increase in mass, but there will be decrease in the concentration of the electrolyte. I hope that helps you. Now, there is now a salt bridge. Remember, we said I've been referring to the two metals that are inside the electrolyte. I didn't talk to the salt bridge. Now, we have a salt bridge, which is now indicated there. This is our salt bridge. So our salt bridge. Even in the previous question that we were having, we had a salt bridge. Is this one? This is a salt bridge. You can see there are ions there. There is negative and positive. You can see there is positive ion and N ion in there. So we refer to that as a salt bridge. So maybe you're asking yourself, what is the function of this salt bridge? So I want to explain that to you. To say the salt bridge, its function is to complete the circuit. This is an exam question. We'll ask you to give us the two functions of the salt bridge. So we're saying a salt bridge complete the circuit. It means if you don't have a salt bridge, there won't be any voltage there. Even that light bulb that we have seen, the zinc copper that I used there, it won't light if there is no salt bridge. So your salt bridge is like a switch, because immediately when you put it in, then you will be able to have your circuit becomes complete. The second function of the salt bridge is to maintain electrical neutrality. This one is a question, and there are many questions that you will get that will ask you what is happening in the salt bridge. So it maintains electrical neutrality. It maintains electrical neutrality. If I go back to this slide that we're using, you will have seen we said the two electrons were moving from here, from zinc, they were moving towards copper. So when the electrons move, obviously electrons are negatively charged, which means there is more concentration of the negative charges. It's increasing on the cathode side there, because the electrons are moving in that fashion. And then what happens is that when the electrons are leaving, they are leaving zinc 2 plus, which is positively charged. So it means when the solution increases, even the positive charges are increasing in terms of this side of the solution. Now, what happens is that in the salt bridge, we have a salt. In this case, it was potassium sulfate, KSO4. Now, that salt, you remember, is K plus and SO4 2 minus. So if you're having a salt like that, you will know that, okay, the SO4, because it's negatively charged, it will come here where there is more zinc 2 plus being formed in order to neutralize the positive. So you see how the neutralization happens. So I want you to understand it this way. N ion will move to the anode. N ion, remember the anode, we're given anode here. So it must be the negative one that comes here. N ion must move to the anode. I want you to understand that. N ion from here. Remember, we said ode is from the word electrode. N anion. So anion will migrate, will come and neutralize in the solution there, because we are having a lot of the solution that is increasing. So anion will go to the anode, cation or the positive charge will go to the cathode. So don't even lose marks about this question. Always know that the positive charge will go to the cathode, because here we showed you positive. Hence I was writing it as a positive. The T there, I just write it as a straight line so that you don't forget it's a positive. So the cations, the positive charges, moves to the cathode. The anions moves to the anode. Please remember that question. That question has been in the papers, and there are times where learners lose marks. So I'm saying to you, be able now to remember so that you don't unnecessarily lose marks. So I hope it helps you. Now we have this that we refer to as cell notation. Cell notation. Let me take you back to where we started. When we started, we said you will have zinc losing electron to become zinc 2 plus. And then we said copper 2 plus, because it has a higher standard reduction, it will gain electrons to become copper. Now, what will happen is that I said now number 3, the step number 3. Step number 1, you knew which one is going to lose electron, which one is going to gain electrons. After that, we are saying you did what you call net. So you add the two, you get net or overall cell reaction. Overall cell reaction or net. I said to you, before you write the overall, you must ensure that the number, you balance the electrons. The electrons must be balanced. So you are having 2 electrons on the product there of zinc 2 plus, you are having 2 electrons on the copper 2 plus, they are equal, so you can cancel them. Then what is on the left here, the zinc and the copper 2 plus, you must write on the left. So you'll write zinc plus, copper 2 plus. This forms zinc 2 plus 2 electrons. Now, you see, that is the first remark. So you are able to write the overall or the net cell reaction. Now, from there now we're saying cell notation. Is cell notation, remember we said the first one there is the anode, the second one is the cathode. So when you write the cell notation, we are saying A, B, C. For you to remember that you start with the anode this side. So you will write anode is zinc becoming zinc 2 plus. So you have to know that, okay, for the anode is zinc becoming zinc 2 plus. That is the anode. The anode is zinc becoming zinc 2 plus. Remember, in between we're having a salt bridge. Those 2 lines, they show you the salt bridge. I just told you now the function of the salt bridge is to complete the circuit and to maintain electrical neutrality by allowing the flow of charges. You saw how the charges flow. We said the cations, the positive ions, they will move to the cathode. The anions or the negative ions, they will move to the anode. Don't forget that. So we have the salt bridge is indicated by the 2 lines. So when you see those 2 lines, you know that they represent the salt bridge. Then we are having on the cathode, we are having copper 2 plus forming copper. So you can see this slide nicely explained for you what I was trying to show you there. To say you are having the zinc now. This line here that I've drawn there, that separates the zinc and the zinc 2 plus. It shows that zinc is solid. Zinc 2 plus is aqueous. So it shows that these are different phases. We refer to that line as a phase boundary. It's a phase boundary. You only write it if 2 substances have different phases. A solid and an aqueous in this case. Sometimes you can find that you have aqueous and aqueous. You can't write a solid line because they will be having what? The same phase. When the phases are different, like a solid and aqueous, you will write a solid line. That line shows that this serves as a phase boundary. It's showing that you have different phases. The double line in the middle, it shows you the salt bridge. It shows you the salt bridge. Now, you might be asking yourself now to say, where is this 1 mole per cubic centimeter coming from? We see we've written after the solution, when we have the plus is the aqueous solution there, we write the concentration of that. Remember, I said to yourself that when I was referring to the table, I said it's a table of standard reduction. Maybe I must go to the table. We said it's the table of standard reduction potential. So what we are simply saying here is that this is the ability of gaining electrons under standard conditions. So there are standard conditions that you must know. The standard conditions that you must know, number one, is a concentration of 1 mole per cubic decimeter. You can refer to it as initial concentration. It's fine. Initial concentration of 1 mole per cubic decimeter. Number two, temperature of 25 degrees Celsius. Temperature of 25 degrees Celsius. Sometimes you can write it in kelvins, it's allowed. You can say 298 kelvins, it's still fine. You can use degrees Celsius or kelvins, it's still fine, it refers to the same thing. Number three is the pressure. Atmospheric pressure. You know, atmospheric pressure is 101.3 kilopascal. So these are three standard conditions, which means these galvanic cells that we are referring to, these values that we are having standard reduction potential, these voltages that you see here, they were we achieved them, we got them under standard conditions. It means the concentration must be 1 mole per cubic decimeter, the temperature must be 25 degrees Celsius, pressure must be 101.3 kilopascals. What I want to emphasize for yourself is to say, if we ask you to name two standard conditions, you will refer to the concentration and the temperature. Remember, pressure applies where gases are involved. However, those other two will always almost be there. So if you say write two, you must write the first two, which is temperature and concentration. But now if you say three, you will include pressure. If there is a gas, you can include pressure. So you have to understand that pressure affects gases. Hence, I'm saying if we say two. Now, one of the mistakes learners make during the exam is that we can say write down standard conditions, and then you say concentration, temperature, and pressure. That would be wrong. You can't say concentration, pressure, and temperature, or Cape Town. So we like to call it CPT. You can't say CPT because you have to state what is the concentration. It must be 1 mole per cubic decimeter. What is temperature? It must be 25 degrees Celsius. What is pressure? Must be 101.3 kilopascals. You can say 101.3 kilopascals, or you can just say 1 atm, because that is atmospheric pressure of 1. So you have to understand that that is the standard conditions that you know. So if I'm to recap as to what have we done today, you will agree with me that we have learned what is loss of electron. We said is oxidation. We said a substance that undergoes oxidation is a reducing agent, and that substance is what? Is oxidized. So you have learned that. Now we said the substance that undergoes gaining of electrons, the process is called reduction, and the substance is called oxidizing agent. What is oxidizing agent? We said it's a substance that undergoes reduction, or the substance that gains electrons, or the substance that is reduced. So you have to know that. Don't forget, we said an ox. We said an ox, that stands for oxidation occurs at the anode. And we said a red cat, where we said reduction occurs at the cathode. So if you have understood this, and I was able to take you to the table of standard reduction potential. I used the table 4B. I am quite sure that in our next lessons we'll be able to still refer to table 4A. So now I'm saying to you, when you go to the table, the substance that is the highest standard reduction potential will undergo reduction, meaning that it won't be changed. It will remain the same. And in table 4B, that will be the second, the one at the bottom of your two choices that you'll be having. It will be a bigger number. That one will undergo a reduction. However, the one with the smaller number there at the top of the table, it will undergo oxidation. So don't forget that the standard reduction potential tells us which one will undergo oxidation, which one will undergo reduction. So the one with the highest standard reduction potential undergoes reduction. The one with the lowest standard reduction potential is reversed. we go backward when we write it from that table, when you copy it. Remember, when you write the half cell reactions, you don't use 2 arrows. You are only using 1 arrow because these are our half reactions. And you are able, before you write the net or before you add the 2 halves, you have to first balance the electrons. Ensure that the electrons are balanced. If the electrons are balanced, what is on the left, you write on the left. What is on the right, you write on the right. I indicated to yourselves that the agent are always on the left of your half reactions. Please don't forget, your oxidizing agent, your reducing agent, they are on the left of your half reactions. And then we talked of the cell notation. We said you will say ABC when you are dealing with this one. So when you're saying ABC, the anode on the left, and then you have the phase boundary, and then the anode, you always start with how the anode started. We started with zinc, it became zinc 2 plus. That's how we wrote it there. But you have to write that line there, which you say it shows phase boundary. A straight line shows phase boundary. It shows that zinc is solid and zinc 2 plus is aqueous. So for as much as the phases are not the same, you will write that solid line that indicate that there is different phases. The double line, we said it stands for the salt bridge. The salt bridge, we said it has 2 functions: to complete the circuit and to maintain electrical neutrality by allowing the movement of ions or charges. Now, what you have to remember, I said to you yourself again, that to the anode, N ions will go to the anode. Cat ions to the cathode. What are they doing there? They are going to maintain electrical neutrality. So I hope you have enjoyed this lesson and everything went well, and then we don't have problems. And then in our next lesson, we'll be able to deal with exercises now. We'll be able to treat as many questions as possible so that you really understand this. And this is a section that you are saying that 28 marks from this section. Please collect the whole of it. I think you will enjoy the rest of your day. Thank you very much.